Okay, this is going to be a video for the quadratic formula for complex numbers. One thing that we do have to go over is how to simplify a radical with a square root in the denominator. What you have to do that is multiply the top and bottom by that same square root. So that's going to be the square root of 40. Now, square root of 8 times the square root of 8 is the square root of 64. Now, if you take the square root of 64, that's going to be 8. So the shortcut is whatever you take the square root of, that's the part that you get. Now, the 40, you're going to break down 2 and 10, 2 and 5. Here's your pair, okay? So I have 2 square root of 5 up top. On the bottom, I have 8. If I reduce that, I could divide both those by 2, which would give me 1/4, okay? This one would be the square root of 8 over the square root of 6. Okay, so this separates like this. It's sort of a math trick. Okay, that'd be square root of 48 up top. This would be 6 in the bottom. If I break down 48, it's 2 and 24. It's 2 and 12. It's 2 and 6. It's 2 and 3. Pair, pair. I'm going to take 1 per circle group. And that's going to be a 3. Okay, so 4 square root of 3, all over 6. A 2 could go into both of those, so it'd be 2 square root of 3 over 3. Okay, all right, that is simplified. All right, so why don't you stop the video and try these? Okay, now let's talk about the quadratic formula. Okay, basically, your quadratics will do one of 3 things. Okay, we talked about this in nature of the roots. But this is a concept of 2 reals because it crosses the x-axis in 2 spots. Okay? This is the idea behind 1 real because it crosses that in 1 spot. Now, if it's 1 spot where it crosses the x-axis, 2 spots here, well, what about this? This would be 0 real. Now, what we're going to call that is 2 imaginary. Okay? All right, so we don't actually call it 0 real, we call it 2 imaginary. Okay, so we're going to do the quadratic formula just like we did in the previous lesson. Okay, so that's set equal to 0. That's my A, that's my B, that's my C. As a reminder, here's what the quadratic formula is. All over 2A. So what I want to find is the B squared minus 4AC. Okay, all right, so my B is negative 12, my A is 4, my C is 28. Now, you can type this right into the calculator. Go ahead and put parentheses around it. Okay, that gives you negative 304. Okay, all right. All right, now what you want to do is you want to break down. Okay, because I got to take the square root of negative 304. Now, what does that mean? We learned how to break down stuff before. This time, all right, what am I going to have? I'm going to have the I. Okay, so negative 304 would be 2 and 152, 2 and 76, I believe. Confirm that's right. Okay, divided by 2, 252, 76, yep. 2 and 38, 2 and 19, and 19 is prime. So I got a pair, I got a pair. Now, when I go to break this down, I can take 1 per circle group. I also have to account for that negative, which is the I, and I have 19. So I have plus and minus 4I square root of 19 all over 2 times 4. Now this, remember, this is opposite of B, so that's going to be 12. Okay, so I got 12 plus and minus 4I square root of 19 all over 8. Now, is there a number that all 3 of those could be divided by? Yeah, 4. So that'd be 3 plus and minus 1I square root of 19 all over 3. All over 2, I'm sorry. All over 2. Okay? All right, and we're going to practice a few of those. Okay, so what I got to do is move this 56 back. I got negative 2x squared plus 20x minus 56 equals 0. Let's find the b squared minus 4ac part. Okay, here's my A, here's my B, here's my C. So what I should have is 20 squared minus 4 times negative 2 times negative 56. Okay, so 20 squared minus 4 times negative 2 times negative 56. All right, it's going to be negative 48. Okay, all right. So if I break down negative 48, that's 2 and 24, that's 2 and 12, that's 2 and 6, that's 2 and 3. Pair, pair. Now, since I have that negative, I can bring the 2, I can bring the 2, and because I have this negative, I have to bring down I. Now, what did I not circle? What did I not cross off? 3. So that's going to be 4i square root of 3. Okay, so plus and minus 4i square root of 3. This stands for the opposite of b, so that'd be negative 20. All right, 2a, which is negative 2. So negative 20 plus and minus 4i square root of 3 all over negative 4. Okay, what could all three of these be divided by? 4. So negative 5 plus and minus 1i square root of 3 all over negative 1. And that would be my answer. Okay? All right, let's do another one. I move this 12x back. Make sure you put that in the middle. Okay, don't leave that outside. Remember, it's got to go x squared x, then number. B squared minus 4ac. Okay, this is my a. This is my b. This is my c. Negative 12 squared minus 4 times 3 times 33. Okay, so negative 12 squared minus 4 times 3 times 33. Okay, that's negative 252. I don't think 252 is a perfect square root. It is not. Okay, so then I want to break down that. That's 2 and 126, I believe, yeah. 2 and 63. Yeah. 63, no, 3 and 21, and then 3 and 7. Okay, pair, pair, okay, and that negative. So I got 2 times 3 times I, square root of 7, so that's 6i square root of 7. Okay, this is opposite of b, so that'd be 12. This is going to be 2 times 3, so that's 12 plus or minus 6i squared root of 7, all over 6. Now, they could all be divided by 6, so 2 plus or minus 1, 7. You can put this as a 1, or you could just leave it like that. Okay, all right, either way is fine. Okay, all right, let's look at this one. All right, so I gotta get my b squared minus 4ac, okay? Now, here is my a. What is this for? This 4 is c. So what in this case, my b would be 0. So 0 squared minus 4 times 9 times 4, okay? 0 squared minus 4 times 9 times 4. It's negative 144. Now, I know that the square root of 144 is 12. So what would the square root of negative 144 be? That's going to be 12i. Okay, so what I got is I got plus and minus 12i. My b is 0. Then this is 2 times 9. So 0 plus and minus 12i all over 18. Okay, all right. Now, you can look at this a couple of different ways. Okay, all right, this would just be positive 12i divided by 18, and then negative 12i divided by 18. If you did that, I'd be fine, but really if you divide those, that's going to be 2/3 I, and that would be negative 2/3 I. So that's technically what the answers would be. If you got to this point, I would be okay with that. Even this point, that's not so bad, okay? All right? So I would like you guys, I'll give you a bunch of time, go ahead and solve those. Okay, describing the nature of the roots, okay? Now, here's the idea, okay? If you have a positive number, and nature of the roots, all we got to figure out is our discriminant. Okay? All right, if I get a positive number, that means I have 2 real. If I get a negative number, that means I have 2 imaginary. if I get 0, I've got one real. Okay, all right. So b squared minus 4ac, my a would be 1, my b would be 8, my c would be 16. So I got 8 squared minus 4 times 1 times 16. Okay. I'm going to get 0. Okay? So what does that mean? I have one real. Okay? Number 2. Here's my A. Here's my B. Here's my C. So negative 5 squared minus 4 times 3 times negative 2. I got 49. So what does that mean? 2 real. Okay? I got my A, my B, my C. Negative 2 squared minus 4 times negative 6 times negative 18. And that was negative 18. Negative 428. So what does that mean? 2 imaginary. Okay? All right, now, what's my A here? My A here is this. This is my C. What's my B? My B would be 0. Okay? So I got 0 squared minus 4 times 1 times 64. Negative 256. So that's going to be 2 imaginary. Okay? All right? And so this means the graph crosses once. This means the graph crosses twice. The imaginary means it doesn't cross the x-axis at all. Okay? All right? So you can go ahead and pause your video and describe the nature of the roots. Okay? And that's going to conclude the quadratics lesson for complex numbers.